Okay, welcome to my channel. My name is Ange, and this video we're going to be dealing with unit vectors. Okay, so we've been dealing with vectors in our previous videos. So if it's the first time watching our videos on vectors, I advise you go back to the first video so that you can follow up to this point. But if you've gotten the basics already, of course, we can just get on with it. And if you enjoy watching my videos, please don't forget to subscribe to my channel, share with your friends, a way of encouraging me to make videos like this. Good. Okay, so let's just get right into it. Okay, so a vector having its modulus, or you can say its length or magnitude as 1, is called a unit vector. Okay, great. Now, this unit vector could be pointing in the direction of another vector. It says, let u be a vector, then the length of vector, and then the length of vector u denoted by this. So if we denote the length of vector u as that, then the unit vector pointing in the direction of vector u is defined as this. So the notation for a unit vector is just maybe, like, for example, if I use u with a little hat above it, it means the unit vector pointing in the direction of vector u. So this is the explanation. If we have vector u in this direction, okay, if it points in that direction, such that the length of vector u is not 1, let's say it's more than 1, okay, so the unit vector pointing in that direction will be a vector whose length is 1, and it points in the same direction as vector u, but the difference is that the length is exactly 1. So let's say something like that, okay, where the length from here to here for this particular vector is 1. So this is called a unit vector. So if this is vector u, then this has to be vector u hat, which is a unit vector pointing in the direction of vector u. Great. Okay, and this is a definition. So you just say u over that. Now, going back to this definition, we had that the length of a unit vector is 1. So you may want to check out. So how am I sure that from this definition that the length of this unit vector, of course, the length of this vector u hat is going to be 1. Well, you could just think about that in your mind. If you want to find out what the length of this unit vector u hat is, you will just look at it. This denominator is already a positive number, so we just have to take the length of the vector u, and of course that's exactly what we have already in the denominator. Okay, so that just cancels everybody out and give us 1. So that's it. Okay, great. So you don't need so much work. All right, so that's just to show you that at least the definition makes sense. Okay, so let's look at what we call basis or unit basis vectors, and I'm going to first of all look at them in R2. Okay, so these are the vectors, talking about vector I hat, vector j hat, and vector k hat. Good. So if we have let's say Cartesian plane, okay, look at this, then that. So this is like the x-axis, this is like the y-axis. So you want to see how we can define these vectors. Okay, so if a vector points in this direction, okay, if the vector points in this direction and this points in that direction, vector I is a unit vector pointing in this direction, but with unity as its length. That is 1 as its length. So if from here to here is 1, we'll call this unit vector I, and it's defined as this 1, 0 or 0, 0. Okay, let's start off with I2, with R2. Then for unit vector j, since it's going to be pointing in the y direction, it's going to have 0, 1. So if you want to represent this vector I hat on the Cartesian plane, you know that the value of x is 0 when y is 1. So you just from here to here. Good. So you could just have something like this. A vector from here, the origin, up to this point, something like that, right? It's exactly on the x-axis from 0 to 1. Then if this is 1 on the y-axis, you may want to also represent the j hat vector, which will be from 0 to 1 like that, and you just have from the origin, you move straight up to 1 like that. Good. So that is how you want to think about it. You may say, okay, what about the j? What about the k vector? Well, this will be applicable in R3, where we have x, y, and z axis. Then the k will now take up z axis pointing in the direction, and then having units is a length as 1. Okay, so that's it. So maybe let's just extend it to R3 so that we could include the k hat vector. So in R3, we will have something like this. I hat will be pointing in the x direction, having its entries as 1, 0, 0. J hat will be pointing in the y direction, having its entries as 0, 1, 0. And then k hat will be pointing in the z direction, having its entries as 0, 0, 1. Good. Each of these, their length is 1, and then that's it. So those are the unit vectors we want to look at. That's the basis unit vectors. Okay, so I'd have some example, and this example, it was going to agree with the way we chose to represent vectors. That is one of our previous videos. I showed you that representation of vectors in this way. Let's say, assuming we have 3, 5, 1, that we could also represent it as 3i plus 5j plus 1k, which is just k. That is k hat. Good. So this example is going to really help us understand how these two are exactly the same. Okay, so let's assume we have a vector. So as an example, so let's say we have a vector v which has entries 3, 5, and negative 1. 3, 5, and negative 1. Okay, so let's see how we can rewrite this vector in a different way involving I, j, and k, right? So since it is in R3. So this is what I'll do. I'll first of all split this apart. So I'm going to split it as the sum of 3 vectors, where each of the 3 vectors has only one non-zero entry. So this is how I'm going to choose it. I'm going to take 3, 0, 0. We know about addition of vectors. So I'm going to add it with, of course, 3. The position of 3 has been filled up. So we now have only the position of 5 to fill. So we have 5. I'm going to put 0 right here. And then I'm going to add this as 0, 0. Of course, you know, negative 1. So if we add these vectors, given that we're going to add the corresponding entries together, 3 plus 0, 0 is 3. 0 plus 5 plus 0, 5. Then 0 plus 0 plus negative 1 is negative 1. Okay, great. Now we recall multiplication of vector by scalar, that I could easily factor out the 3, and I'll be left with 1, 0, 0. And then we add this with, okay, we add this with, can factor out the 5, I'll be left with 0, 1, 0. And then lastly, I can factor out the negative 1, and I will have 0, 0, 1, of course. Good. But you recall that 1, 0, 0 is a vector pointing in the I hat direction, and then the j hat direction, and then that. So that's the unit vectors. So you can simply just call this 3i plus, this is just 5, and then that's j, and then minus 1, then this is k. Good. So that tells us that this vector could be written as that. So that confirms the representation. All right. So if I have a vector, that's like an example 1. If I have a vector like this, let's say vector w, which has this, and I wouldn't want to go beyond R3, not because you cannot, just that just want to wallow on this. Of course, the space we live in is R3. Of course, 4 dimension is, I don't know what to even say about it. Okay, great. So let's talk about let's say we have a vector like this, negative 1. Let's say we have 10, then we have 7. Okay, you could easily just join this one with I, join I there, join k here, and join j here and join k here. That would be negative I plus 10j plus 7k. Good. So that's simple. So if you have to understand why this is, you just have to go through these steps and then apply the same thing right here. Okay, that's nice. Now you say, okay, what if from this definition, what if you want to find a vector pointing in a direction, a unit vector pointing in a direction of a given vector? All right, so maybe that's the kind of example you want to do now, and this is it. So you want to find a unit vector, call it, you want to find a unit vector, call it u hat, okay, pointing in the direction of vector v. Good. given that vector v is, from the example we used earlier, the first example I used 3, 5, and -1. So given that vector v is that, so you want to find a unit vector, let's call that unit vector u hat, which points in the direction of vector v. So coming back to this definition, you could see that to find a unit vector u hat pointing in the direction of vector u, we define it as that unit vector we want to find is vector u divided by its length. So in this case, we will have to find out the length of vector v. They will now say vector v divided by length will give us a unit vector, which we now call u hat. Good. So to find the length of vector v, you can recall in our videos, in our previous video when we dealt with length of vectors, so you could go back there and check just to revise. We were able to discover that to find the length of vectors, you have to just take the square root of the sum of the squares of the entries. So in this case, we have the square root of 3 squared plus the square root of 3 squared plus the square of 5, that's 5 squared, plus the square of the third entry, which is -1, so just say -1 squared. So in this case, this will give us the square root of 3 squared is 9, 5 squared is 25, that's 34, then -1 squared is 1, so that's 35 when added. Good. So that means that the length of vector v is simply just square root of 35. Now to find vector u, the unit vector u, which is pointing the direction of vector v, we'll just take this ratio, say vector v divided by its length. Alright? Good. But that will give us vector v, which is what we have here as 3, 5, -1, divided by its length, which we found as square root of 35. And of course, you know that. Okay. Great. Now, from the previous example, which we were able to rewrite it in this way, so I'm going to use that notation. That will be 3i plus 5j minus k hat. Good. Divided by square root of 35. Okay, so I'm going to split this apart such that for every direction we have it, separately. So that will be 3 over root. I'm going to split the fraction. Okay, we have that. Then this is plus 5 over square root of 35 j, and then this is minus 1 over square root of 35 k hat. Good. So this right here is a unit vector pointing in the direction of vector v. You could say, okay, how are we sure this is a unit vector? Well, I already showed you from this definition that you could easily take the length of this and you will see that they will just cancel each other out and give us 1. But you could go ahead and play around with this. To know if the length is 1, just take the square root of this thing squared plus this thing squared plus this thing squared. And of course, from what we got here, you would easily know that when you sum them up, you're going to get just 1. Well, what will happen to the i's and the j's? Okay, so for now, I just wanted to know that when you take a product of a vector with itself, in this case, a scalar product, you just get 1. With time, we will get to know, or we get to verify this result. Same thing with j times j is 1, k times k, that's dot product, is 1. Again, with time, we'll get to verify it. Anyway, okay, so thanks for watching. If you enjoyed the video, please don't forget to subscribe to my channel and see you in our next video.